All right, welcome everyone to Masinski Makes. This is the AI variety show. I'm the AI show. We talk about techno-feudalism, we talk about artificial intelligence, we talk about programming languages, we talk about woodworking, DIY. We'll have a little bit of everything. A lot of home maintenance probably is what I'm expecting over the next few months, doing a lot of stuff to the house. I started off the week strong by writing an NSF scholarship grant. So I got that submitted on Tuesday morning. Okay, so finished that up. Spent a lot of the rest of the week, I've been reading about incremental, sort of incremental programming, and especially DBSP, differential data flow, that kind of thing. I built a programming language with Claude Fable, so that's something we're going to look at a little bit later. I worked on my gutters, so I finally finished my gutters this week. This is a project I've been working on for the whole summer now. And then I took a ton of stuff to the dump. So I had a ton of extra crap laying around my house, mostly parts of a fence, and I rented a U-Haul truck, loaded that stuff up, got it put off to the dump here. This is the kind of place, you know, it's surprising. In New York State, you would think it's the kind of place where you couldn't throw anything away, right? And that's kind of true in some places, like in Ithaca. That is kind of how it is. It's really hard to get rid of junk, right? But I am actually pretty lucky. I can live the Southern dream of being able to drive just down the street and throw away as much stuff as I want in the dump. You just pay, you know, 30 bucks or something, and then you can unload a truck worth. And in my case, I got a giant U-Haul cargo van, loaded it up with stuff, put a big tarp down. You know, you load it up, you get it all to the dump, you pay your fee, and you can unload as much as you want, which is great because those big pod things cost like hundreds of dollars to get them to dispose of the stuff. All right, so let's talk about the gutter project. So I've been working on this gutter project for a long time now. I was quoted a cost of $4,400 by a third-party company to do the gutters. They were going to do what's called seamless gutters. The way the gutters work is basically as follows. If you're going to do DIY, you go to the store and you buy segments of gutter, and you basically you seam them together. There are a variety of ways of doing this. You can either use pieces that sort of join them together, or you can lay them end on end, which is what I ended up doing. And then if you regardless of what you do, use some silicone seam-based sealant, and then you put the pieces together and you rivet them together by using these little aluminum rivets. All right, so you do that, and you end up with this big, long piece of gutter. You know, in my case, 25, 30 feet on the short side, and then like 50 feet on the long end of my house. And then you basically get, a friend and a ladder, and you go hang them up with all these brackets. Now, I priced out a price of around, I think, $1,400 worth of material to do this myself. And the material was all the gutters. I got 16-foot gutters from Home Depot, aluminum K-style gutters, 5 inches. That seemed to be the standard. I got the 3x4-inch downspouts, but really seaming the gutters and hanging them up was kind of the hardest part. And I would say, well, maybe that's a lie. Okay, so just to take you back, when you're doing this process, in my opinion, the most important part is going to be actually preparing the surface. So, if you have a modern house, you're going to have basically an aluminum fascia, which is the board that faces the exterior of the house, hanging under the sort of the roof, right? When you look at the house from the side. So that would be aluminum now. You'd have an aluminum soffit, which is the piece that kind of hangs down over the eaves. That would all be aluminum. That's great because those things don't rot. Unfortunately, my house is a little bit older design, and I mostly try to honor the house in its current state. It has just wood on the side, and then it's primed and painted, right, for those, for the fascia and for the soffit. And so, I basically just got some wood trim boards. I took out all the pieces that were rotten. So this is kind of the most important part, is if your house has any rotten wood on the fascia, which might happen if you're using just like wood instead of, PVC or something like that, which is kind of the advantage, doesn't rot. That's the alternative. So if you're using regular softwood, of course it could rot. And then what you have to do is you have to cut out the various sections that have been rotted over the years. Would I do it again? And I think the answer is, I think maybe yes. I think if I were on a one-story house like I have now, I do think it's mostly worth it to do it yourself, although you definitely need several friends to help when you actually come to do the final hang of the gutters. I feel like if they had been able to do everything that I did for $4,400, I totally would have taken the deal, and I think that would have been great use of money. but I don't think they actually would have repaired the fascia board in the proper manner and stripped off all of the paint and reprimed and repainted everything like I did. I think that's just way too much work. It was a huge amount of effort. It took me at least, I would say, probably 5 to 6 days worth of just sanding and priming and painting, if you add that all up over the course of like the 6 weeks that I was working on this. So the prep is something that I think there's no way a gutter company would be able to do that, especially the carpentry required. A gutter company is probably just going to be subbing out that work. So yeah, I think if I were to do it again, I would get what are called cut and drop. So basically, you can call a local gutter company and they will come out with their machine and they'll pump out the sizes of gutters you want, and then you just put the end caps on them, you drop the downspout adapter things and you cut those into the gutters, and then you just hang them up. And so I think I would have done that because seaming them together, it's a little bit frustrating and it's a source of leaks. And so if you could truly get them seamless and you can call around and find a company that will come out and just cut and drop them, and then you do the installation and you do all the removal and stuff yourself, I feel like that's a pretty good value if you're somebody who's willing to DIY it. Now, if it were really high up on the house, you know, like a 2-story house or something, I mean, it already felt pretty dangerous and sketch to work on, you know, my 1.5-story house. I was able to set out some plywood, especially over my pond. I have a little pond in the backyard, which is unfortunately just taken offline for now. As I decided I needed to repair this section of the roof, I had to basically take the water out of the pond, cover it up with plywood, and use that as a footing for the ladder as I access that section of the roof to do sanding and removal and painting and all of that kind of stuff. So that was just a huge pain, and it was pretty scary to be up that high working with, like, you know, the violent sander. But it was still a really fun project. I mean, and one of the main reasons I did this was just to have kind of a fun project to do myself in my spare time. So I think from that perspective, it was cool. I learned a lot. I got to do some carpentry, so that was pretty cool. I'm really happy with how the back of the house came together and fixing up all the wood. It feels really solid, and so I'm looking forward to that being all fixed now. All right, so I got this non-alcoholic beer here, and one of the most interesting things about this beer is it's a 0.0% beer, but it still has the original bottle cap, so you can't just twist it off. And I feel like if you're already at the level of a 0.0% beer, you know, you should just make it a twist off one, right? Because if you're in a setting where you're having 0.0% beer, I don't know, it feels like you would always want to, you know, just be able to put it out, you know, on the porch or something like that on a hot day, right? But no, that's not the way it works. I wonder, is it like some status thing? You know, it's opening it up, it makes you feel like a proper alcoholic or something. I'm not really sure, but it tastes pretty good because the regular Heineken tastes so bad that the alcohol-free basically tastes the same, right? So, all right, so now we're at the segment of the show where I respond to some tweets. So earlier this week, I released my language Puffin, which is basically a vibe-coded compiler. It's basically a Scheme compiler. It's like Shea Scheme. It's a subset of Scheme that was based on basically my undergraduate classes. All right, so Chromotorque asks, out of curiosity, care to explain the background motivation? Aren't people just going to offload all programming to LLMs in the future, who at that point could just as well write everything in COBOL? And this is a question that I think many people are asking. And the question is basically about the value of code as an artifact in a world where basically all code could be written by LLMs. And many people are making this observation that if you have a sufficiently advanced AI, there's really no need for a formal language at all. Because to any degree that there might be necessary formal properties that you would need to explicate, you could just write that as whatever natural language prompt. And I think partly embedded in this idea, because the clear counterexample, the thing that people would say is, well, there's these formal hard constraints that are just things that need to be articulated, right? And it makes sense to use logic to do that. And I think the critics might say, well, the AI is going to be so good that there's not really going to be that much need to be able to use things like formal logic and reproducible semantics to be able to reason about these things. So I don't really have a great answer to this stuff. I guess I would say the role of Puffin was mostly to have an experience using vibe coding to create a little programming language. And my hope was that I could use that to experiment with things like maybe optimizations or just various ideas I had about programming. Maybe if I wanted to add something like information flow types or, parallelism or compilation to GPUs, right? It's kind of nice to have like a nice language that you could use for day-to-day functional programming, which is basically how I use, Scheme Racket. But maybe that has a slightly different feature set. In my case, I added, gradual types, simple algebraic data types. I added a simple notion of modules, which is kind of roughly similar to Rackets, inspired by SML. And yeah, I think it was a very interesting experience in, doing language design. But yeah, it didn't teach me anything in a deep way, and it wasn't academic in nature at all. It was mostly, just a fun experiment. So I think everybody is collectively questioning the value of code now. And I think people are rightly pointing out that the primary function of code is to be used as an interface to humans. Code is kind of the original HCI, right? Because it's the ultimate way in which you can interact with the computer. It's the ultimate way of making your thoughts explicit and reproducible and systematic in a way that they have a formal semantics that can be reasoned about coherently, right? And I think there will always be value in having a clear, coherent semantics that is simple to understand to the human. And then the question becomes, is natural language just the ultimate way of doing that? Is that the kind of thing where, is there going to be any relevance to code in the future, given the fact that natural language can apparently, write large software artifacts? And I think that's reinforced by the fact that many engineers on a day-to-day basis are writing almost no code. Maybe they're reading the code, right? And they know how to write small chunks of code in principle, especially if they were to team up and sort of be aided by the LLM, although, it might be the case that they don't actually understand that code if the LLM were to be taken away from them. But in any case, I think, this is a very clear thing to question, especially since LLMs are just so good at writing code. And then, of course, the next step is, why have code at all, right? Why not just eliminate the middleman? We have the LLM, we can describe how to do it. The LLM knows how to generate the right low-level code, the assembly, the binary, or whatever. So why not just have it do it, right? And I think this is where there is kind of a clear answer. So I think the first answer is just efficiency, which is to say it's just going to be way, way faster to use a traditional compilation strategy rather than to have all of the burden of the neural burden that is going to be placed onto a model by having it generate and do the inference for the semantics, right? The code has a semantics. Unlike natural language, whose semantics is just very ambiguous and contextual and defined by, whatever the self-attention over all human text ever written is, right? Unlike that setting, code actually has a semantics. It has a written semantics. In fact, that's why we build programming languages, is to give hopefully simple, coherent, objective semantics that have properties that can be reasoned about. And I think this is going to be a very important thing for many reasons, in the sense that even if the LLM is capable of generating awesome code, and LLMs become the way in which we generate almost all code in the future, or maybe even all code to some approximation, there's still going to be value in having languages, because just LLMs themselves, first of all, just raw LLMs, pieces of the LLMs like the next token predictor or whatever part of the transformer, they're not especially good just by themselves at one-shotting answers to problems, right? I think the real innovation that we've been seeing over the past, few years, and especially ramping up over the past like 12 to 18 months, has been this insight that basically when you take a really powerful LLM, but when you give it access to these very simple tools to act as verifiers and sources of ground truth, then the LLM can just become like orders of magnitude more powerful, because those things, those simple checkers and verifiers, they can serve as very simple reasoners that can do things that would be very challenging for the LLM. You might argue that in fact, there is going to be a semantics, right? But it's not going to be a semantics that's written out in a way that humans would maybe traditionally understand it. It might just be some other, weird language that if a human were to look at it, it wouldn't make any sense at all. But there is a coherent semantics, and it makes it perfectly clear to the machine. And so then I think that's a very interesting thing to consider, to be honest. I mean, I would love to know more about that. And if anybody has any work that that they know about that attacks that angle or tries to look at this, please let me know. But I do think that's where it comes back to this idea that we use code for more than just executing programs. We also use it to form our own understanding, right? And so in the same way that as we write, papers, we're writing to be able to develop our thoughts, right? We're using our writing to develop our thoughts. Well, it's the same thing with code, at least in some settings, right? For many settings, maybe this is not true. In fact, for many engineering settings, you're writing code to achieve some goal. But at least when we're students, we're writing code to be able to actually build our mental models of things. And, I think that's not going to go away anytime soon, even though, of course, it's going to get aided by LLMs.
All right, so now let's talk about the puffin language. So like I said, it's descended from a compiler in my class. It's a graduate class on compiler design, and it follows Jeremy Seek's book, which builds a pretty significant subset of scheme. I added match patterns and quasi-quoting. That's something I use all the time and is basically essential for my kinds of workloads on a day-to-day functional programming basis. I added gradual types with a very simple kind of algebraic typing and consistency-based bidirectional typing, following a pretty traditional formula that I mostly understand, but the implementation, could be wrong. And so, something we'll look into in future weeks. I also added a standard library of sets, hashes, so dictionaries, and these are all immutable by default, although they have mutable variants. I added SML modules and signatures, but not functors or first-class modules or anything like that. So in my mind, this is a very simple, covers, 90% of what you want kind of module system, and a typed FFI. And the goal of this language really is just to, see if I could do it, but also to serve as this idealized version of Racket that I could use in my day-to-day programming. So if I think about, what do I really want in a programming language? It's mostly, Racket scheme, but I would like to have things like algebraic data types. So here I have this define type form, which is a new form that allows me to define an algebraic data type with a number of constructors, and those constructors can reference, recursively the definition of the type. And all of the algebraic data types within a module are in one big mutual fixed point. So you can recursively nest them and build types that way as well, which also seems like a pretty natural way to do it at the module level. The code is self-hosting and Racket free. So there's a bootstrapped compiler. There's an old version of the compiler in Racket, and now there's a version in Puffin. Like I said, there's gradual types. I'm not going to talk a ton about that. There is a tutorial. So if we go to the tutorial here, Puffin for Racketeers, it shows us that we've got things like let loops, so you can do that. We've got immutable hashes. One choice that I made that I thought was pretty interesting is just that, for me, I'm not really somebody who uses numbers to do anything really serious other than the basic stuff, right? That you would do in sort of your day-to-day, computer science education. And so I chose for this language just to do 61-bit integers. Why is it that? Well, there are a few bits for the tagging. that allow you to tag if you have a big data type that's like 64 bits and you're dealing in a language where some of those bits could be boxed or represent other kinds of classes of values, then you give up a few bits, in this case 3, to get the representation, but we get 61-bit tagged integers, and that's basically ubiquitous throughout the language. And to me, this just felt very natural. I don't really do much programming with floats or anything like that, at least when I'm doing this kind of programming. If I was going to be doing that kind of programming, I would probably be using a GPU instead. And so maybe I'll try to build some GPU languages in the future and cover them on this channel. So I've got pattern matching. So this is just a traditional match statement that you might see from Racket, right? We've also got algebraic data types. And like I said, this uses a gradual type system. And when you match on things, it will give you helpful informational errors about things like totality and coverage of your match statements, which it can infer using the type signatures. Everything starts as being sort of unknown, which is kind of the way that you do gradual typing, right? And then you add sort of casts at places where you might need to check. And then you check consistency with this non-transitive relation that checks consistency of the typing derivation. So let's see, I'm not going to go a ton into depth here. I'll let people read if that's something that they want to do. I guess I will just point out and say there's also a browser-based version of Puffin. So we can see we've got a little program here that defines an arithmetic expression language as an algebraic data type. And then I define this function eval_expr over the argument e, which is annotated and has to be an expr, and I'm saying this whole function returns an int, and so I'm going to match on e, and the type system will figure out how to complain at me if I don't do it correctly. So let's comment out this thing, and I'm going to get a type check warning. Match on expr is non-exhaustive, missing num, and that's in main.puffin on line 10. And I guess it's just finding this whole function. So maybe that's not so good. We might like line 12 or a range or something. But I fix it. Here we go. All right, so it works. I've got a bunch of other examples here. I really tried to focus on PL examples. So here's an example, ANF converter. All right, I think I looked this through and it looked reasonable for this small language. Closure conversion. All right, so some examples of manually creating closures. A simply type lambda calculus type checker. All right, so we can see that. And then a bunch of other basic stuff here, I guess. There's just a very basic DPLL-based SAT solver. This is not even using CDCL or anything like that. It's just kind of branching and doing the traditional DPLL algorithm. Let's see. And then, of course, every functional programmer's first function they learn, the factorial function.
All right, so next week we've got some exciting stuff happening. So I have been moving the stuff from my garage into some U-Box U-Haul storage containers that I've got on my driveway. And the reason is I'm getting my garage floor epoxied next week. So my garage floor is currently just this, crappy epoxy that somebody did from Home Depot, did not prep correctly, and has now completely failed. And I watched a video on doing it yourself by this guy, Mujin. And after watching that video, I convinced myself that I absolutely could not do it myself. It looked so hard to do this. Especially the tools involved to do it properly are quite expensive, if impossible to rent. And so I hired this company to do it. I'm pretty excited they're coming out next week. And so I have to store the stuff from the garage, which is my workshop. I have to store that in the U-Boxes. And so I'm taking all the stuff and putting it into the U-Boxes today and tomorrow, and then they'll come out on Monday, do the floor. And then I will have some fun projects to do next week. I'm going to be starting to work on sort of putting the stuff back in the garage, which is building basically a new workshop out. I'm going to be building some cabinets for that workshop. I'm going to be finishing up a tool cart that I've got in that workshop now. I'll be setting up also a new dust collection system. So I ordered about $600 worth of parts from this company called Oneida Air Systems, which makes high-end woodworking related air quality systems. They sell a quite expensive unit for like 2,000 bucks that would have been maybe the ideal way of doing this, but I figured I could have some fun, try to reuse some components that I've already got and make a new dust collection system that would work for me. So I'm going to see if I can do that. And then another big one is just setting out the mulch. And so that's going to be a big chore for next week. I'm going to have to clear up the garden beds. I got all the crap out of the yard this week, and so I'm kind of ready for it at this point. I just have to go through, get rid of all the weeds, till up a bunch of the dirt, and then go spread a ton of the mulch. And then I think the beds will be ready and the exterior will be kind of going. Another thing I've got going, I've got a ton of projects around here these days. So another thing that I'm working on is that I'm painting the house. So any portions of the house where the paint is chipping and falling away, I try to sand those down, prime them, and repaint them just to make sure they're tight from water for the next year and the next winter going forward, since the winters are especially brutal. All right, so thanks for tuning in to this episode of Mosensky Makes. We'll be back next week with more discussion of artificial intelligence, programming languages, DIY, woodworking, other things like that. This channel is not sponsored by anyone, and it never will be. The views represent purely my own, so if you're interested in that kind of thing, feel free to like and subscribe, and I'll be happy to see you back around in the future. All right, see you then. This is your artificial intelligence variety show. What is it?